Good day. I am Janelle Anby Abarcas and I am here to discuss the direct current and alternative current, electric power generator, and electrical measurements.
We gather information from the book, which is the Architectural Utilities to Electrical and Mechanical Equipments. Some thoughts and ideas from the web for a simpler terminology for a better understanding and additional information. First, let us define electric current. An electric current is a stream of charged particles, such as electrons or ions, moving through an electrical conductor or space. It is a continuous flow of electrons in an electric circuits. Ibig sabihin, ang electric current daw usa nga urihan particle na may adahin atoms wherein adi an electron wherein it is a negatively charged, proton positively charged, and neutron or neutral. For a better understanding, we have here an example. A battery. Suludhan battery, may ada iton electrons. It na electrons, and siya ito ang nagpuproduce para magkamay-ada ang electricity. Para mas maunawaan pa naton, let us proceed to the definition of direct current and alternative current. So, direct current or DC is electrical current which flows consistently in one direction. Ibig sabihin, ang flowhan electrons consistent na uusala na direction. While alternative current or known as AC, the direction of the flow of electrons switch back and forth at regular intervals or cycles. Ibig sabihin, an AC kuno or alternative current, nagbabalik-balik ang iya direction han electrons. Generally, an DC, one direction, and AC, pabalik-balik ang direction. Now, let's proceed to electric polarity. Electrical polarity is a term used throughout industries and fields that involve electricity. There are two types of poles, positive and negative. These represent the electric potential at the end of a circuit. A battery has a positive terminal, positive pole, and negative terminal. So, ang polarity ko no, ang siya ini and may ada positive and negative ha battery. Makikita ta ini ha battery. So, ang tawag hini haira na positive and negative, asya ini ang positive polarity and negative polarity. Hira ang responsible para makagawas ang electrons tikang ha battery. The pole with more electrons is said to have negative polarity. The pole with fewer electrons then has a positive polarity. When the two poles are connected by a wire, electrons flow from the negative pole towards positive pole. This flow is called electric current. Answering ko no, didi ang negative polarity may dahiya mas damo nga electrons kaysa positive polarity. So, pag gin-connect ko hira ha wire, ang electrons kuno tikang ha negative pole na agi tikang ha positive pole. As a result, magkakamaayadahin electric current. Now, let us proceed na to electric power generator. It is also called dynamo, a machine that converts mechanical energy to electricity for transmission and distribution over power lines to domestic, commercial, and industrial customers. Generators also produce the electrical power required for automobiles, aircraft, ships, and trains. Any type of generator works by converting mechanical power into electrical power through electromagnetic induction. Electric generator, very familiar inihiya aton kay kada may brownout, pag mayaman nan may kaya ka, may daka mo hini na generator. Pero ha electric generator may adaliwat duha na klase. Ang direct current generator nan alternating generator. Didi may babaroan ta kung ano na klase nga generator ang pwede ta gamiton sa mga buildings, mga shop, mga residential houses. Nanbisan ano daw nga generator nagana by converting daw the mechanical power into electrical power sa pamamagitan ng electromagnetic induction. Electromagnetic induction na nanabo ini kapag an electric current naagi ha shifting magnetic field which allows an mechanical energy na ma-convert ha electrical energy. An siya ini an reason kaya magkakamay-ada electricity tikang ha generator. So, adi na. An AC generator is used to power smaller electrical items in your business, such as coffee machines, computers, etc. AC generator are the most common backup generator. Typically, AC generators have a frequency of 60 cycles per second. An AC or alternating generator, siya yung gigagamit daw mga small na mga items nga kailangan hin electricity like computers, coffee machine, mga amiton. And on the other hand, we have a DC or direct current generator. It is used to power larger electric motors, even as big as those used in subway system. And DC naman or direct current generator, yung gagamit sa mga dagko na mga establishments such as subways, electric motor groceries, malls, and many more. Now, let us see the advantage of AC and DC generator. So, adi an advantage an AC generator. It is cost effective, perfect for small electrical appliances in the office, lower maintenance needs. While DC naman, generator advantages, simple design, runs large motors, smooth voltage. So, makikita naman ang mga advantage. AC, mas makakatipid ng effective lalo na sa mga gugti na mga appliances. While ang DC naman, dako ni advantage lalo na sa mga dagko na mga garamiton. Now, lastly, we have electrical measurements. Electrical measurements are the methods, device, and calculations used to measure electrical quantities using transducers. Physical properties such as temperature, pressure, flow, force, and many others can be converted into electrical signals, which can then be conveniently measured and recorded. Electric measurements is simply a tool na ginagamit pag-measure han electricity para may baruan ta kung pira nga electricity and present. Iba-iba iton hiya na klase na measurements na may ada kita, but it has the same purpose and makita and ma-measure an electricity na ada. And that is the end of my report. Hopefully, may nabaraan ka mo tungkol sa AC and DC current or alternative current and direct current, electric power generator, and electric measurements. Thank you and God bless.
Power and energy. First, let us discuss power. Power is the rate at which work is done or the rate at which energy is consumed or produced and is measured in watts. The electric power in watts produced by an electric current I consisting of a charge of Q coulombs every t seconds passing through an electric potential, where Q is electric charge in coulombs, T is the time in seconds, I is electric current in amperes, and V is electric potential or voltage in volts. And now, let us discuss energy. At any given time interval, the energy consumed or provided depending on your perspective, where E is the electric energy, V is the voltage, and Q is the amount of charge moved in the time interval under consideration. We can relate the total energy consumed to the power by integrating over time. Positive energy corresponds to consumed energy and negative energy corresponds to energy production. Note that a circuit element having a power profile that is both positive and negative over some time interval could consume or produce energy according to the sign of the integral of power. And of course, there is a difference between energy and power. The difference between these two is that energy is what makes change happen and can be transferred from one object to another. Energy can also be transformed from one form to another. Hence, the power is the rate at which energy is transferred. It is not energy but is often confused with energy. The watt is the most commonly used unit of measure for power. It measures the rate of energy transfer. Power in electric circuit. The unit of electric power is the watt. A larger unit of 1000 watts is the kilowatt. The power input in watts to any electrical device having a resistance R and in which the current is I is given by the equation. This is true for both A to C and D to C circuits. However, since the resistance of an item is generally not known, but the circuit's voltage and current are known, it would be preferable to calculate power in this equation. So here are some examples. And that's all. Thank you and God bless.
Good day, this is Edson Sisa Payton. What is energy in electric circuits? Since power is the rate of energy used, it follows that energy is equal to power times time. Therefore, amount of energy used is directly proportional to the power of the system and to the length of time it is in operation. Since power is expressed in either watts or kilowatts and time in hours, we have four units of energy: watt hours or WH or kilowatt hours or kWh, energy used for 1 hour. What is electric load control? A method of load control is efficient utilization of available energy to produce a high load factor. This results in a lowering of demand charge, levying of a charge for power in addition to the normal energy charge. This demand charge is primarily useful in encouraging users to reduce to their peak loads. In so doing, energy use is also reduced somewhat, and secondarily in a reduction of energy costs. An ancillary, but important, benefit is the maximum utilization of electrical power equipment, which normally runs underloaded. This results in small equipment, lower first cost, and less space utilization. The control devices and systems are variously referred to as load shedding control, peak demand control, peak load regulation, power use control, and permissive load control.